Greetings, I am Barbara Craig. This paper has been prepared in collaboration with my colleague, Dr. Ken Stevens. Ken and I are both New Zealanders with a long interest in ICTs, education, and issues of equity. Ken concerned with rural schools, and I with schools serving underprivileged and multi-ethnic communities. In this paper, we argue that in the age of the internet, the future of schooling lies with learning networks. This challenges the concept of the traditional school operating within its own four physical walls, with its own distinctive culture and history, and frequently in competition with others for its students. A shared learning community of schools offers professionally managed and supported digital resources and services that would be too costly for individual schools to provide for their own teachers and their learners. For the teacher to collaborate, they must learn to move from the privacy of face-to-face communication in a physical classroom to a virtual one where colleagues can and do observe one's teaching methods. For the learner, a networked school offers personalized learning, the possibility of connecting the individual to individual opportunities to pursue a limitless range of academic interests. The vision is connecting staff and students to experts, local and global, 24/7 access to service and resources, and teachers and learners publishing content on the network. The paper is based on the experience of two networked projects. The first, the Vista School District Intranet, was part of a broader pan-Canadian initiative to prepare Canadians for the information age, led by the Information Highway Advisory Council in the mid-1990s. This was an electronic network of small rural schools. Iceland, New Zealand, and Finland were the other early experimenters with e-learning networks in remote communities. The goal: to provide geographically isolated students with extended educational and indirectly vocational opportunities. The other project, Wellington Loop, connects 6 inner-city high schools in an inner-city community through the use of several Web 2.0 technologies that facilitate networking and collaboration. It is one of several so-called loops or aggregations of schools into a shared online environment, working towards a vision of a national education network where every school is a member of a local loop and all loops a node on the national network, connecting up to Karen, a dedicated education network, not slowed down by traffic on the public network. Both projects have roots in some early New Zealand rural school networks. Casatech, the orange shading in this map, originated before the age of the internet, where audiographic tools, the synthesis of audio conferencing and computer-generated graphics, text networked by telephone lines, were used to teach from one site to students in several remote sites. Casatech continues today using video conferencing technologies. In both Canada and New Zealand, the impetus to use new technologies to teach across the network was driven by rural schools under a threat of closure as students moved out of their local communities to large urban schools with greater curriculum offerings. Prior to the new Web 2.0 collaborative technologies into the teaching and learning space, the internet was primarily about content, and the flow of information was one way. The technical challenge in these early days was to provide reliable download connectivity in order to deliver resources into the classroom. The Rural Canada Initiative used this genre of technology, a learning management platform. Web 2.0 or social media allows a two-way flow of information so that users can both read resources on the internet and publish their own content to share with a global audience. Web 2.0 applications, those that support self-authoring, facilitate creativity, collaboration, participation, and the sharing of content between users. These are the technologies used by the Wellington Loop project. Newfoundland and Labrador are organised into 10 districts. The Vista School District covers a large geographic area with a population of about 35,000 people and an economy supported by fishing, forestry, farming, mining, aquaculture and tourism. 8 schools within the Vista District, together with the Tally Learning and Rural Education Centre of Memorial University, formed an intranet within which senior science courses were taught in open classes. In these 8 schools, students were involved in advanced placement, biology, chemistry, mathematics and physics courses, which enabled them to gain credit towards their first-year university program. The courses for these 4 science subjects were developed by teams of classroom subject teachers in collaboration with graduate students and professors in education and in the sciences at Memorial University. Students took part in both synchronous, real-time learning through video links where they could interact with the teacher and their peers. The rest of the time was spent offline using the tools available in Web C2. Web C2 also enabled the instructor to track the progress of each student. These are the features of the learning platform, Web C2. This is just a screenshot of one of the physics classes. And here's a screenshot of meeting point going from one site to many. Asynchronous learning and open learning sites. Questions were raised about the students' ability to engage in independent personalised learning. The early New Zealand research, Cantatech, found learners were able to obtain satisfactory results in national examinations within an electronic network of small rural schools. In the New Zealand situation, students, however, usually had at least one teacher on site to assist them. In the Canadian intranet, this was not always possible. Students were unanimous at the conclusion of the school year that to be successful in an AP online course, it was necessary to work independently, cope with a high volume of work, and be willing to ask questions of teachers and other learners as problems arose. Some of the pedagogical concerns were the difficulty of securing and maintaining instructional design expertise in the preparation of courses, maintaining motivation and control in the network classes, and then coming up with a common schedule or timetable. Online sessions were scheduled in the morning when network traffic was at its lowest point, and offline sessions were scheduled in the afternoon. It required both academic and administrative inter-institutional management and coordination across the 8 schools. Wellington is the capital city of New Zealand. One purpose of the Wellington Loop was, quote, to establish, maintain and promote a high-speed fibre optic learning network. Schools located in inner city Wellington had the advantage of partnering with CityLink, which was an open and high bandwidth fibre network flung across the trolleybus network in downtown Wellington that provided internet access to inner city businesses. These schools also were physically close to 2 universities and therefore able to connect to CAREN, the Kiwi Advanced Research Network, that supports international research collaborations between universities in Australia, New Zealand and the US. The speed of CAREN allowed schools to use high-definition video conferencing and access to applications such as Google Earth. The Wellington Loop offers 6 core services to schools: MySource Matrix is an open source web content management system with support for Web 2.0 tools used for linking the school websites and used for the main Loop portal. Moodle is an open source learning management system and as such is a depository for shared teaching resources that can be accessed 24/7. It is also a place for online blogging and community building between the 6 participating schools. Mahara is an e-portfolio tool where students and teachers can share, store and publish their own content and work. It's used in a lot of project work in a number of curriculum areas, and students also use it as a social software application to customize their personal profiles and develop their CV. The wiki is a space to share artifacts and resources, and ClickView is one of 3 supported services to share video content and provides a large library of video-based learning resources. Crucial to success of the Wellington Loop project was an evaluation to identify the challenges for working within a network and the benefits. The Wellington Loop runs as a non-profit organisation that generates the funding to support the ICT infrastructure. Each school pays to connect to the network in addition to a membership fee to cover the services that are hosted on the network. The 6 initial participating schools have not been able to meet the costs of running the shared applications, the network access, the licenses, and support of the software, and the professional development for the users without quite a heavy sponsorship of business partners. The project had always planned to bring in the other 135 schools in the region once the value of collaboration was visible in order to gain a more efficient economy of scale. The goal of the Loop in its trial phase was to get a few selected applications well established and then be able to persuade other schools that there were benefits in gaining the network. The technical challenges. First, how to achieve seamlessness. Services had to be available with just one click. Teachers needed the assurance that when they clicked on any application icon, the services would work. In terms of benefits, in each school, there were just a handful of teachers keen to use these new technologies. Professional development was the biggest issue that arose from the project. In each school, there were a handful of teachers keen to use these new technologies, but the follow-up to this trial has been a grant for collaborative professional development.